Greetings, I am Maleficious, and I'm back with more of Shenzhen IO. Last time, well, I didn't really get anything accomplished, so I'll have some solutions for you in a moment. I've actually got some tea tonight, though it's herbal tea, which means there's no actual tea in it. It's Celestial Seasonings Fireside Vanilla Spice Blend, which is a pretty good blend. And yes, it is Celestial Seasonings, not Celestial Seasons. No idea why I called it that the last time I had some of their tea. And I have no idea why I thought they got their ingredients only from Boulder. Because I've been to their factory, and I've been in their mint room, and they obviously get their spearmint and peppermint from around the world. And I know they use Madagascar vanilla in some of their blends, so what I think happened was I was confusing Celestial Seasonings with the Boulder Dushanbe Tea House, which does get the ingredients for its teas from around Boulder. At least I think so. That's what they said the last time I was there. But yeah. Just gonna have a sip of tea. It's been cooling for about 15 minutes, or, well, more like 20 now. Yeah. Let's move on to the solutions. Yeah. I managed to get these done, like, the morning after I figured this out, I think. Sounds about right. Well, if not an hour afterwards, then definitely morning afterwards. But yeah, taking myself out of the recording obviously allowed me to look at the bigger picture. And so here's my solution for the Aquaponics maintenance robot. And as you can see, I actually managed to fit a RAM chip in. I figured out how to get that working. So it's now just 3 MC4000s, 2 of them are 4000Xs, and 2 MC6000s. So this one just reads the values sent across the radio RX. The first thing it does is it moves a value of 0 into the address for the RAM chip, so it resets it each time. Then it moves the next 3 values that it gets from the RX chip into the RAM chip. And it should work because it's not using the first value from the radio RX chip at all, so then it just sets itself to sleep. Now this microcontroller, its job is just to read the stuff that goes into the RAM chip. And so I start out with SleepX X0, which I don't think is strictly necessary, but what is necessary is I have to slow this microcontroller down one so that this microcontroller can move a value in. Or it might actually work because, yeah, no, it needs to slow down one because the next thing it does is it moves a value of 0 into the addressing. So it's using the second set of pointers in the RAM chip because it's got 2 sets of pointers, the A0 and D0 and the A1 and D1. Then it moves whatever values in the 0 position into the accumulator, and then it tests if it's less than 0, which means it's trying to check if it's -999. And if it's not, I move the accumulator out the X3 into this microcontroller, because that's the destination. And then I move the next 2 values into this microcontroller, which will handle the tools. And this works because, again, the pointer moved after I moved the value in it into the accumulator. So then it moves the second one and then the third one in. And then this sets to sleep. Now again, this microcontroller handles keeping track of where the robot is supposed to be. So it's set to sleep until it receives data from the X1 port. And I could use the X0 port, but I figured save on some wiring. So I move that into DAT, which will hold the destination port, and again, the accumulator will hold the current position. So this starts the loop, and I've started the loop with test equal accumulator and DAT, because this is important. When I had it at the end, there were problems that arose. So if they are equal, it's in the right position, and I jump to the end, which I end by moving a value of 1 across the X2. Basically, I'm just giving this a signal that it's time to start. So if it's not equal, then it falls through, and I do test comparison between the accumulator and DAT. So if the accumulator is less than the DAT, then that means the destination is farther to the right of where the robot currently is. So I move value of 1 to x3 and add 1. And if the accumulator is greater than the data registry, then that means the accumulator is to the right of the destination. So I move a -1 to x3 and subtract 1. And I set this to sleep 2 and then jump back to the loop start. Then this microcontroller actually handles moving the motor. So again, I've got an initialization at move 50 P1 so that it's set to its default. It sleeps until it receives data from this microcontroller. I move it into the accumulator, and I do a test compare with 0. If it's less, I need to move 0 because we're moving backwards. And if it's greater than 0, I move 100 because it's moving forward. I set it to sleep 1, and then I move 50, and set it to sleep 1 again. So that handles that. Then this microcontroller, which handles the feeding and cleaning tools, it sleeps until it receives data from this handling. And so I move the first value into the accumulator and the second value into the data registry. Then I test if the accumulator is less than 0, which I may not actually need, but I've got the handling there just in case. So if it is, I jump to the end and set it to sleep. And so if it is 0 or more, then we have valid values for the running the tools. So I set it to sleep until it receives signal through X0, which only comes from this microcontroller. Then I test it. Yeah, test is greater than 0, so I can start work. So move 100 P1, sleep the value in the accumulator, move 0 P1, move 100 P0 to feed, sleep the value in that registry, move 0 P0, and then ends. That should work. So if I just click through the advance, you can see in the simulation the robot moves and cleans and feeds, and then goes here, and then it gets this order here to go return to the 0 position and clean for 4 and feed for 1. And so it does that, and then this is the point where having the test equals at the end tripped it up because it would automatically sleep. Well, it moved 50 to P1 and slept 1, so it didn't get the data. It needed to start cleaning immediately because it was in the right position. So it does that and runs, and this one worked, and I tested the next one through advance. It should work. So let's just run simulation and watch as the robot moves automatically, and I'll have some tea. And all of the test results were successful. My production costs, power usage, and lines of code are much higher. So obviously this could be done a lot easier, but I don't know how to yet. But I'm satisfied with the solution, and I want to move on. Alright, from Wu Li Li. I've received word that Mr. Sun was happy with the result of our work here. Clearly it's part of a much larger project, but nobody I speak to will say anything more. So there's that. Then the other thing I tried was creating the kill switch. Oh no, wait, this is something different. Whoops! Okay. Well, I didn't read that out, so no idea what's going on quite yet. Okay, so I managed to solve the timekeeping issues I was having with this. So it starts with this MC6000. It just, I move first two values, first value into the accumulator and the second value into the data registry. And in this case, that way, if we get an X bus packet, then the first value will go into the accumulator and then the second value into the data registry. Then I do a test compare of the accumulator with -1. Because we know -1 means do nothing, and 0 or 1 means we have to switch power off or on. And if it's less than -1, then it has to be a -999 and means we're ignoring it for now. So, if it's less than that, oh wait, if the accumulator... Yeah, I moved 0 to X1, and then jump to the end, and then set this to sleep. So if we go down to X1, this is the timekeeping controller. So I've set it to sleep until it receives data from X0, and test if it's greater than 0, and this will be important in the handling later. So if it is greater than 0, I'm resetting the accumulator and jump to the end where it's asleep. But if it's not, then it falls through. I add 1 to the accumulator, then I test if the accumulator is greater than 4, which means 5 or more time units have elapsed with no instructions. So if it is, I move a -1 out the X1 port, and then set it to sleep. Now then, if it's greater than -1, then I can move then first I move the accumulator through X2, and then the DAT through X2. So, then I move a value of 1 to X1 in order to reset this. And because if it's exactly -1, then we're supposed to do nothing and let it fall through and reset. Now then, this other MC4000, and these can be replaced with 4000X's, because we don't actually need the simple IOs in this case. Anyway, it sleeps until it gets data in, and then I do a test compare with 0, because we're only getting either a -1, a 0, or 1 in the first case. So, if it's greater than 0, then that means we've got a 1, which means we're switching power on. So I do a digit set of the corresponding digit given by X0, and we set it to 1 so it switches on, then I jump to end. If it's less than 0, that means I got a -1, so we have to shut down. I move a value of 0 to the accumulator and jump to the end. But if it's exactly 0, I just do a digit set of X0 to 0. Which means I'm pretty much ignoring... Well, no, I'm not ignoring the command, am I? Well, no, I'm not ignoring the command because it takes the second X0 in from here. Yeah, and if it's -1... Yeah, and if it's -1, it just shuts down. So we get to end, and we just move the value, whatever value is in the accumulator, out to the X1, and set this to sleep. And this handles the states, because if it's in a 0, it goes out P0 to power 0. If it's in the 1's position, it moves it to power 1. And if it's in the 2's position, it moves out power 2. And of course, this is pretty much a binary state. But yeah, I tested this twice. It should work. So yeah, it runs through. We're switching powers on and off. Automatic shutdown and restart. And again, automatic shutdown, restart. Powers on. Shutdown, restart. And simulation. And there we go. I was slightly over the most common production cost. I used a lot more power and more lines of code. But I'm satisfied with this solution, so it worked out pretty well, I think. Okay. From Zhang Ji. Sweet, can't be too careful when you make robots. Am I right or am I right? I am learning some more casual style English from Joe. G. From Carl Teskey. You scared me for a second there, Jay. Yeah, that's a little worrying. Okay, but that's the first 15 minutes, so... Well, yeah, I can move on to next project. And, wow, we're getting a lot of projects in. So, we looked at this close a little bit. Smart Grid Control Router from Wu Li Li. I'm pleased to say we have been selected for another Sun Hao Shan project, a simple data router for smart grids. Mr. Sun was never interested in civic infrastructure before, to my knowledge, so I really wonder what he's planning. May ask around. My uncle's had dinner with him once or twice. From Zhang Ji, we can do it. Note, these X-bus inputs are blocking, so we will need to connect all inputs so they can be read at once simultaneously. G. Well, that might prove difficult to manage, but maybe I can come up with something. Okay. Meter in and meter out are X-bus inputs and outputs that connect this node to a building's smart grid power meter. Lower in and lower out are X-bus inputs and outputs that connect this node to a node with a lower ID number. Higher in and higher out are X-bus inputs and outputs that connect this node to a node with a higher ID number.